Okay, today we'll be looking at the questions for the midterm for EVT 1000. First question asks, the average exhaled carbon dioxide concentration from a human breath is 3.9%. Convert this concentration value to parts per million. Express answer to the nearest unit percent. So first, let's write down our information. We are working with CO2. The concentration is 3.9%. And they're wondering what that is in ppm, parts per million. Looking at this problem, it's a relatively easy problem. The CO2 part does not matter. All you gotta do is convert this to a decimal and multiply it by a million. So to do that, you're gonna do 3.9 divided by 100, which is equal to 0.039, and multiply that by a million to get 39,000. So 3.9% is equal to 39,000 parts per million. Look at the second question. It asks, the density of a given object is known to be 3.01 times 10 to the negative fourth pounds per inches cubed. Determine the density in grams per milliliter. Express your answer into 3 decimal places. So they give us the density, which is equal to 3.01 times 10 to the negative fourth pounds per inches cubed. And they want it in grams over milliliters. So a few things we need to know before starting. We need to know that pounds is equal to 453.592 grams. We also need to know that 1 inch is equal to 2.54 centimeters. 1 inch cubed means that'll be equal to 1 inch cubed is equal to 2.54 centimeters cubed. So now an inch cubed is equal to 54 to the third, which will give you 16.387 centimeters cubed. So now we can relate centimeters cubed to milliliters, because centimeters cubed is equal to 1 milliliter. So that means that inches cubed is equal to 16.387 milliliters. Now, to convert this is in pounds over inches, so over inches cubed, which is equal to 453.592 divided by inches cubed, which would be 16.387. When you type that into your calculator, you get 27.680 is what we'll go with. So now you've got to do some simple math. You do 3.01 times 10 to the negative fourth. Multiply that by 27.680, and you will get 0.0083. They wanted it to 3 decimal places, so it's going to be that would be the density. Simple enough. moving on to our last problem, and probably the most difficult. It asks what volume of oxygen at 30 degrees Celsius and 0.21 atmospheres is required for combustion of 2 grams of propane gas. So let's write down the information it would like. It wants the volume of O2 at 30 degrees Celsius and at 0.21 atms atmospheres for the combustion of 2 grams of propane. This is probably going to be the hardest problem. First, we need a balanced chemical equation. So what's happening here is C3H8 is being added to O2 to make, and through simple displacement, single displacement, you're going to receive the carbon dioxide and H2O as a product. Now to balance this on this side, at the moment we have 3 carbons, 8 hydrogens, and 2 oxygens on the reactant side. On the product side we have 1 carbon, 2 hydrogens, 3 oxygens. So we need to get this balanced. All you have to do to balance it would put a 5 right there, a 3 right there, and a 4 right there. That now gives us, continuing with the 3 and the 8, but now we have 10 oxygens. And over here now we have 3 carbons. In this case we'll have 6 oxygens plus 4 times 2 is 8. So now we have 8 hydrogens and 4 more oxygens, so plus 4 is equal to 10. So now that it's balanced, we will now look at the equation we'll be using, which would be PV is equal to nRT. So to do this, we'll need to find PnRT. First, let's look at P. P is our atmospheres that they gave us, so it'll be 0.21 atm. V is what we're trying to find, so we won't write that down. N is the number of moles. So to find the number of moles, it's quite simple. Look down here. 38H8 is equal to how many grams? Well, carbon is 12 grams by itself, so 12 times 3, plus hydrogen, which is 1 times 8, is going to give us 44 grams. But we only have 2 grams, so do 2 divided by 44, multiply that, and you get 0.0455 moles of propane. Now here's the trick. That number of moles is reacting with 5 oxygen. So to find the relationship, you just take the number of moles of propane you have, multiply it by the number of oxygens you have, to then find your number of moles in the relationship of number of moles of oxygen you'll need, which will give you 0.2275. So you'll need 0.2275 moles of oxygen to react with the 2 grams of propane. Next is R. R is a constant, and in this case, since we're working with atmospheres, the constant is going to be 0.082, if I'm not mistaken. And then T, the temperature. Right now, the temperature is in 30 degrees Celsius. We don't want Celsius, we want Kelvin. So to convert Celsius to Kelvin, you add 273, which will give you 303 degrees Kelvin. So now before we start plugging numbers in, let's rearrange our equation to solve for V. So all you do is divide by P, and you will get V is equal to nRT over P. Like V is equal to number of moles, so that's going to be here, 0.2275 times the constant, which is right here, 0.0821 times the temperature, which is right here, which is 303, divided by the pressure, which is 0.21, which will give you, type all that in your calculator, and you get 26.95, well, yeah, 95, we'll just round it to tenths, liters of O2 to react with the 2 grams of propane. All these problems are relatively easy as long as you know what you're doing and how they relate to each other. And with that, all 3 answers are correct. And that is it.